Hello, I want to introduce my project of building Raspberry Pi with IoT Edge and custom vision on board. So first of all, I want to explain why the solution is better than connected solution. So first of all, decision about object recognition, all software we need for it is running on Raspberry Pi. So let's imagine just autopilot car, which is have to go to Azure or any other cloud for making decision. Should it brake? Should it turn left or turn right? Let's imagine this car is just getting off of the network. So collision will be as a result. So we need to build this model on edge to minimize latency and to provide a high level of response. So that's why building a model on Azure in IoT Edge better than, for example, connecting from your device to cognitive services in Azure. So let's take a look first on the schema. So what we have here. I have my Raspberry Pi running IoT device, running Raspberry on Raspberry Pi. I have a Docker containers, few Docker containers running here, and they communicate with each other by HTTP. So I have object detector and camera capture container. Camera capture is capture images and send for detection to the object detection. And then object detector is upload them to the Azure to store somewhere so we can observe the result. Meanwhile, let's communicate with IoT Hub. We can, for example, send updates on our Raspberry Pi through the IoT Hub and monitor the current state of it. We also use container registry for keeping containers. We also train the model on custom vision so you can observe the result on the custom vision portal. We can export the model. Load in Visual Studio, run build, upload new changes to the Azure Container Registry, and then through the IoT Hub update our device. So I build everything in one documentation. I also drop the link, and you can observe basically the project and steps you need to set up to maintain. So first of all, we need a Raspberry Pi, external camera, LAN or Wi-Fi access from Raspberry Pi, probably USB keyboard, HDMI cable, and a small HDMI monitor or some monitor which you can connect through the HDMI. I use my 5-inch monitor just to monitor state. Also need a few fruits. I bring today apple and bananas. We'll demonstrate it soon. Of course, laptop with Visual Studio Code and Azure subscription to build some services. You can build free services, by the way, and use the free tier. Let's take a look in my setup and get familiar with Raspberry Pi. So this is my setup. Right now I have fruits for detection. I also have my camera, which is pointed to the fruits for detection. I have a Raspberry Pi, so there's my Raspberry Pi running in the box. So we have HDMI cable connected. We have a small monitor connected through HDMI cable. We also have a camera. This is my camera connected to Raspberry Pi, and Raspberry Pi is running right now and working with the LAN. So it means we are ready and everything is connected and ready for image detection. But of course we need to train the model. Let's take a look quickly on Custom Vision portal. So in Custom Vision portal, I create a project of object detection, and I use some of familiar for you images of orange bananas, and apples, and also grape. So I upload a few of them. I also upload my custom vision for for better resolution. I use green bananas. I use kind of ready bananas, and I also use different color of grapes as well. So today I have just apple and bananas. I don't have grapes or oranges to detect, and try to demonstrate how it works with just a few fruits. And if I have more, I can detect more. So when you upload all images you need, upload your all images. Each tag should contain at least 15 images. If you upload more, it's good for you and increase better the result. And then we can switch to to performance. And here we can export the model. So if you click export model, you can see Docker file. And from the list, you can choose Raspberry Pi. Raspberry Pi is working on ARM processor. It's different from Intel, might be running on your laptop. So it's a different type of system, and it's need to be built separately as well. That's why we use Docker for it. The Docker is ideal to build the container and run them on Raspberry Pi. But there is some issues maybe comes up when you're running a container on the Raspberry Pi, because if the container need to get access to the camera, this might be prohibited by security settings. So you need somehow work around this problem and allowed to run container with specific permission to get access to the camera. So all the explained details, how to prepare. Yeah, I also have a code in my repo, so you can take a look in the code as well and see how I try to work around this problem. So let's go further. Let's imagine we already have a container downloaded. We also have IoT Hub built on Azure subscription. It's my Azure subscription, and of course we need to register. IoT Edge device. Each IoT Edge device have own key and can be configured from the portal. So, for example, on this IoT Edge device, we can see that agent, hub, camera capture, and object detection is running right now. They are in the running state. There is no errors, and we can manage it from here. We can change, for example, settings. Let's take a look in the object detector. So we have desired values, which we want to set up, and reported values, which we want to set up, which is currently reported by device. So for example, when we do the upgrade of the container and change the version from 26 to, for example, 27 and so on, it is going through desired value and give a command to the device to download it from my Azure Container Registry, deploy and run. We'll do that experiment very soon, but first we need to get connected to our Raspberry Pi. Raspberry Pi is working on my IP address, so I can reach through the network. It's connected to Wi-Fi. So I need to sign in with my super secret password, and I get in. And here I run the command IoT Edge list, which is giving me the current state of my containers running on my Raspberry Pi. And you can see we're running right now object detector of 26 version, camera capture of the 26 version, and agent and hub that is kind of supported containers help my Raspberry Pi to be updated and managed through the portal, through the IoT portal. So far so good. Let's take a look how my Raspberry Pi is getting access to the stream. So that is video stream running from the camera, and as you can see right now, we have a bananas, we have an apple, I also have extra Apple for test soon. So it seems to be video stream is going through, and we can execute analyzing. So the same we can see on inside of Raspberry Pi. For example, if you run command IoT Edge logs camera capture, or let's use camera capture and put the log from it. Better object detector, right? Because object detector is responsible for detecting objects. And I miss O. Okay. IoT Edge. Sorry for typo. So now we get some logs, that is output logs of the current state. And from here we can, for example, monitor that actually object detector is working right now and actually do some recognition. So the recognition going through the JSON, and this is JSON return back from the object detector with the boundaries. You'll see the widths and heights of the square or rectangle where the object is located, and also probability. So we'll see bananas, we'll see apple detected, and we also have some probabilities here. Some of them is pretty low, some of them better, like 39, 29%, 36%. I won't say that it's the best, but it's acceptable. So let's take a look in the result. So my object detector, when it's complete recognition and analyze response, it's upload the image to Azure portal. So in Azure portal we can see, for example, in the storage account output images, and we can view this output we got, and also we can see analyze it output. Let's take a look. So we have analyzed apple and banana. It's pretty small letters, but you can see that apple is analyzed on 37% and banana on 34%. Why is that recognition probability is too low? Because the lights is pretty dark here where I'm recording, and also because the banana which I use not exactly that bananas, which is uploaded in the custom vision, so we can take a look in training images. So those bananas quite different from what I have right now. So to improve probability of recognition, I can take photos from here, upload those photos to my model and train my object again. But let's take another apple. I have another apple, and I put my apple here, and I think it can be taken. So from camera, you should see that I put another apple here. Let's take a look soon. It should be updated on a stream. Give him a minute. I try to minimize communication between object, because it might overload the free tier if you use free tier by number of requests. So as you see right now, apple is coming. So we can take a look at the result of analyzing and refresh the page. Yeah, and this apple is detected as well, and even with a better probability, we'll see 44% is actually that is apple. And my Raspberry Pi is not detected as any fruit, of course.